Hi there, and welcome to this power session with Mama L. And we're going to be learning about scientific notation, part one today. Scientific notation. All right, at the end of this quick session, you should be able to use the correct form for scientific notation and then be able to go back and forth between standard form to scientific and scientific back to standard. So, a little bit of background about scientific notation. Scientists are either A, lazy, or they like to save time. Well, I'm sure there might be some lazy scientists out there somewhere, but really they like to save time. If you think about the things that scientists have to deal with, they're huge things. Huge sizes, huge distances, and also really, really tiny things. Like this number here. It's a really, really tiny amount, but it's a long, wide number for them to have to write out. So they use a little shortcut. And in that shortcut, they have a front number and then a back number, and that back number is 10 raised to a certain power. So let's look at that format really quickly. This front number that we have, you want it to be as snug as a bug in a rug so that you're working with a number between 1 and 10. Okay, so we get all sorts of weird fronts to our numbers, and we get to move that decimal wherever we want to move it so that that number is between 1 and 10. So you kind of have a little power in this scientific notation thing to move that decimal. So I like to put Puss in Boots here with the pathetic eyes saying, please, oh please, keep me between 1 and 10. So let's look at these different examples here and see which ones are in scientific notation form. So I'm going to get my pen out really quickly. Change colors here. Let's go with orange. All right, so this first one, is it in scientific notation form? Is this front number as snug as a bug in a rug between 1 and 10? Well, 6.728, yeah, 6 point something is between 1 and 10. Now, again, on the last slide it said this, but technically it could be 1, but most of the time that's not going to happen, but that's possible. We definitely want it to be less than 10, okay? All right, so the next one, 66,000. Is that snug as a bug in a rug? Well, no, that decimal is actually hidden back here. We would have to move it all the way here to get it to be correct. So that is not in scientific notation format. The third one, 8.0 times 10 to the third. Well, is 8.0 between 1 and 10? Yes, that's in the correct format as well. So that is scientific notation. The fourth one, 0.09721 times 10 to the second power. Nope, not between 1 and 10, right? But we could eventually move that decimal over, but we haven't learned to do that quite yet. We're super close, but we're not there. Last one, 438, is that scientific notation form? Nope, it's not. That decimal, again, that's hidden in the back there. We would have had to move it over this way. All right, so out of these 5 examples, only 2 of them ended up being scientific notation. So when you change a number's format, you're only changing its name, not its value. That happens all the time in math. I tell my students all the time that it's a change in the name, not the value. So keep that in mind. We always tweak numbers to make them work for us so that we can make our math problems a little easier to solve. So let's take a look at these names for 80,000. So as you can see on the left side, I've got 80,000 written a bunch of times. But on the right side, you can see the different ways that I've also equaled 80,000. 80,000 is also 8 times 10,000, or 80 times 1,000, or 800 times 100, or 8,000 times 10, or, of course, 80,000 times 1. And if you look, we're not changing the value. Those all represent 80,000. In fact, if you look at the yellow zeros, there are 4 zeros on the left of the equal sign and 4 zeros on the right of the equal sign. So what happens is, let's say I have a number like 80, okay, and I don't want 80 because it's not scientific notation form, and I want to give that decimal a scoot to the left. Well, if I'm going to take a 0 off that 80 and make it into an 8, I've got to give a 0 to the other side. So you're going to hear me talking about balancing our power in just a second, and that's what that has to do with, okay? But remember, these are all the same value, just different names. Okay, when we're doing scientific notation form, instead of putting 10,000 or 1,000 or 100 or 10 or 1, we shorten it and we use exponents like that. So 8 times 10,000 is now 8 times 10 to the fourth. 80 times 1,000 is now 8 times 10 to the third, and so on. So you can see the difference between these two screens. They're the exact same thing. Something interesting is that anything to the 0 power is 1. And that's important to remember as well. And we'll see why in a little while later. So, like I said, we're going to remember to keep the balance of power, which is good for a power session, right? And you need to always remember that if you're going to move your decimal with that front number, because it's got to be snug as a bug in a rug, then you've got to be moving and changing your exponent for that 10. So when I was learning this, when I was in, 5th, 6th, 7th, 8th grade and working with these kinds of numbers, I would always get confused. Now, am I supposed to move my decimal to the left or to the right? But as a teacher, I found that it really helps to explain it in the sense of balancing the power, because we're always changing from standard to scientific or the other way around. And I couldn't keep track of which direction my decimals were moving unless I thought about it with the power. So in this situation, let's take a look at where our decimal is right now. Well, right now it's kind of hidden in the back there, right? So we want to scoot it over and make it snug as a bug in a rug. Right here, 6.600 is between 1 and 10, right? Not 66 or 660 or 6,600. I've got to put that in the right spot. So I just made a big number small. I took 4 spots of power from that number, so I'm going to keep it balanced and give 4 spots of power to my exponent. So my number in scientific notation form is 6.6 times 10, where my exponent was 1, I'm adding 4 to that, and that's going to be the 5th. All right, here's that number, 0.09721. Well, we have to move my decimal the other direction now, right? So that's why the left-right thing would always confuse me. Well, if I just gave 2 spots of power, making a small number bigger, I have to take 2 spots of power. And this is 9.721 times 10, and then 2, take away 2, is 0. A sneaky one right there. 438, another hidden decimal. When it's a whole number, the decimal is hidden at the back. We're going to scoot that decimal in twice, taking away 2 spots of power, making something that was 438 into 4.38. So we're going to give our power to our exponent, 4.38 times 10, and 5 plus 2, that's 7. 34,123. All right, you might be thinking, wait a second, this isn't in the right format because there's no 10 there with an exponent. Well, we're going to make it happen, right? Here's our decimal hidden behind there. We're going to scoot it so that our number is snug as a bug in a rug. 4 spaces to the left, so we just took a big number, made it smaller. We took 4 spots of power. So guess what? Our exponent, we just give it 4 spots of power where it was nothing before. Now it's 4. 3.4123 times 10 to the 4th. Let's scoot this one to the right until we get snug as a bug in a rug. 4.7. So I just gave 1, 2, 3, 4, 5 spots of power there, which means my exponent would be 10 to the negative 5th. Where it was 0, we had to take 5 spots of power, so that's a negative. Now 12, you might be thinking, what's the point? Why do scientists have to write scientific notation for a number like 12? It seems like so much work. Well, you're right. It would be a lot of work, right? So it's easier, though, to learn these kinds of skills on lower numbers so that when you are dealing with those wide, crazy numbers, you feel more comfortable with the skill, right? So we're just going to go ahead and scoot it one time in, so it becomes 1.2. We took away 1 spot of power there, so we're going to give a spot of power to our exponent, 10 to the 1st. All right, that's the end of this session. Don't forget to watch the next session. If you have any more questions on scientific notation, we'll be learning in the next session how to add, subtract, multiply, and divide with scientific notation. Thanks, guys.